You know that feeling, right? You click an export button, the whole server grinds to a halt, and you're left staring at a progress bar that just never moves. And then boom, it crashes. Well, today we're going to tackle that exact problem, one of the most common headaches in development, how to export massive datasets without all the drama. So let's get into it.
Here's our game plan. We're going to start by looking at why this even happens in the first place. Then we'll walk through a quick, immediate fix and a more advanced, robust solution. After that, we'll zoom out and talk about the core mindset for preventing these issues. And finally, we'll wrap up with a super useful checklist you can take with you.
Ah, yes, the classic screens of failure. Out of memory. Request timed out. I think we've all seen these a few too many times. These aren't just random errors, you know? They are symptoms, clear signs that we've pushed a system way past its limits with what feels like a simple request. So what's really going on behind the scenes that causes everything to just fall over?
Let's start right at the beginning and break down why the most intuitive, the most straightforward way of exporting data is almost always the worst way to do it. It all boils down to a really common but flawed pattern.
This is the one we all try first, right? The get all and loop. It just makes sense. You ask the database for everything, you pull all 2 million of those records into your app's memory, and then you start building your file. But here's the catch. Your server doesn't have infinite memory. This one move sends your memory usage through the roof, and that's what leads directly to that dreaded out-of-memory crash.
So obviously, trying to lift the entire database at once is a bad idea. Let's move on to our first real fix, which is all about being a lot smarter with how we use memory. This is how we take that out-of-memory error head-on and solve it. And the solution is something called chunking. It's simple, really. Instead of asking for all 2 million records in one go, you ask for them in manageable batches, like, say, 100,000 at a time. You process that chunk, you write it to the file, and then, and this is the most important part, you let go of that memory before you grab the next chunk. This way, your memory usage stays low and stable. No more crash. Okay, now that we're processing our data in nice, neat chunks, we can add another really powerful technique into the mix: streaming. Instead of writing all those chunks to some temporary file on the server, we can send the data directly to the user's browser as we process it. It's way more efficient, it uses less disk space, and the user gets that awesome immediate feedback of the download starting instantly.
All right, so we've slayed the memory dragon. That's great, but now a new villain appears: time. Even with chunking, exporting millions of records with complex logic can take a while, maybe a few minutes. And web servers, well, they have a really short attention span. Most will only wait 30 or 60 seconds before they just give up and hit you with that request timeout error.
Now this is a much smarter system. We use background jobs to completely separate that long-running task from the user's initial request. So the user clicks export, and our system immediately says, "You got it, we're on it, we'll let you know when it's done." The actual hard work gets handed off to a totally separate process that can take all the time it needs. Once it finishes, it just sends the user an email with a download link. Easy. And just look at the difference in the user experience. It's night and day. On the left, you've got the old way, where the user is just stuck staring at a loading icon, hoping the server doesn't die. But on the right, with the asynchronous way, the user is totally free to go do other things. So this isn't just a technical fix, it's a huge improvement for your user. It's all about respecting their time.
So far, we've been playing defense, reacting to crashes and timeouts. Now it's time to get proactive. This next part is all about a really important shift in mindset. From just fixing broken things to designing systems that are built to be fast and scalable right from the very beginning.
So at this point, our export is solid. It's reliable, it won't crash, it won't time out. But if it's a really complex report with a bunch of database joins and calculations, it can still be kind of slow. And that brings us to a new question. We made it reliable, but can we make it fast? Like really fast?
The answer is often something called pre-aggregation. Think about it. Let's say you're exporting last month's sales data. That data isn't changing, right? So why would we run all these expensive, complicated calculations from scratch every single time someone hits that export button? It makes no sense. Instead, you can have a background job that runs once a day, does all the heavy math, and saves the final results in a nice, simple summary table.
And here's what that flow looks like. You take your messy, raw data tables, a scheduled job comes along, maybe overnight, and chews through all the numbers, and it spits out a clean, flat, ready-to-go summary table. Now, when the user requests that export, the system isn't doing 10 different joins. It's just grabbing everything from this one pre-built table. It's a trade-off for sure. You lose a little bit of real-time data for a huge gain in performance.
All right, let's pull all of this together. We've journeyed from the initial crash to this proactive mindset. So now let's do a quick, rapid-fire checklist of universal best practices that you can apply to pretty much any data export you ever built.
First up, compress your data. Using something like .gz saves a ton of space and download time. Second, and this one's non-negotiable, secure your data. Encrypt it always. Third, validate everything to make sure it's correct before it goes out. Fourth, pick the right tool for the job. CSV is perfect for cables, JSON is great for APIs. Fifth, monitor and log everything so you can spot problems early. Sixth, if you're doing a full database dump, make sure you're using the correct settings. Seventh, schedule those really big jobs for the middle of the night when traffic is low. And finally, please, document your process. This is your toolkit for building professional-grade stuff.
So there you have it. We went from a simple, frustrating crash all the way to a complete architectural strategy. The biggest takeaway here is that handling data at scale isn't about one single trick. It's about a layered approach that combines smart memory management, asynchronous processing, and intelligent data design. So the only question left is your system ready for what's next?